OK, so now it's time to design TLS. In order to design it, let's first think about things we want to achieve with our design. So it's the usual cryptography properties we know and love. We want confidentiality, integrity, and authenticity. So as a reminder for what these are, confidentiality. Attackers can't read the data that we send over the network. Integrity. Attackers can't tamper with the data that you send over the network. Now, when we talk about integrity, we'll also introduce a new type of attack that we should stop called the replay attack. So in a replay attack, an attacker writes down some encrypted message, or they read their encrypted message and write it down. They might not know how to decrypt it or tamper with it. It's a bunch of ones and zeros. The attacker doesn't know what it says or how to decrypt it or how to tamper with it. But what if the attacker just takes that same sequence of ones and zeros and sends it a second time across the network? If the replay attack succeeds and our scheme is vulnerable, then whoever receives the packet might think that it was intended to be sent twice, even though it wasn't. That would be the replay attack. So for example, let's say you're an attacker, and you have this encrypted channel, and you can read the packets over the encrypted channel, but you don't know what they say or how to decrypt them. Now, if you're able to write down one of the encrypted packets and the ones and zeros, and then just send that exact same packet a second time without any changes or tampering, if the replay attack succeeds and you're vulnerable, the recipient would think that the packet was sent twice, even though it wasn't, and we don't want this to happen. For example, if the packet said pay $10 to Mallory, and Mallory replayed it 20 times, we don't want to send $200 to Mallory. Whoever receives the packet should realize that later ones are duplicates and discard them. So this is an extra requirement we have when we think about integrity, because we don't want this to happen. And finally, there's authenticity, which is making sure that you're talking to the legitimate server. Now, technically, in a connection, there's two people that you could authenticate. You could authenticate the server, and you could authenticate the client. In TLS, we'll mainly be concerned with authenticating the server, because it's more important that Amazon.com is who they say they are than some random person that you're talking to. So usually the client is not authenticated in TLS. The client can be anyone. It's not like Joe is some super important person that we have to authenticate. But the website itself had better be authenticated, so we have to make sure we're talking to the real Google.com and not an impersonator. So those are the three properties that we care about in TLS.